So do dogs have a specific dog microbiome versus like humans who have a specific, can you tell?
Yeah.
Based on a microbiome profile?
Yeah, you can absolutely tell. And what's comforting is there's lots of similarities, but it's very obviously very different. And I'll give you a good example. So the good example is, so we're quite interested in Fusobacterium nucleatum because of the cancer story. And that's it's an oral bug, like you should have it in your mouth. And dogs have lots and lots and lots of it in their mouth and lots and lots and lots of it in their gut in huge volumes. And we were looking at these dogs going, oh my God, they must have bowel cancer. But of course they don't. They're completely healthy. And of course they typically have a gut devoted to proteolytic fermentation. They eat meats, right?
They eat meat,
So their microbes are much less diverse, and they don't have the sort of carbohydrate fermenting engine that we have, although they are omnivores. So dogs, of course, do eat everything, and they're also coprophagic.
Yeah.
And, will lick and sniff and touch everything. So what you do see
is that some sort of inbuilt evolutionary thing that dogs do?
Totally. Yeah, they're scavengers, Like we like to think of them as, we were talking about this last night, lots of people seem to think that there's this close evolutionary relationship with wolves, but actually they're very divergent, and they're not necessarily pure carnivores, and so you see that in their microbiomes. They're very different, and we're very interested in that because, of course, that is obviously a determinant of dog health, and dogs are suffering from the same problems of progress that humans are suffering from.
That's interesting.
Dogs get they get inflammatory bowel disease, dogs get IBS, dogs get asthma, dogs get eczema, dogs get all the problems of a dysfunctional immune system that humans suffer from, and they need the same help and support, and we think the microbiome is a useful way of solving some of those problems.
So are there any microbial therapies for animals?
I had the good fortune to go to a large pet food expo, and it was the Wild West. There was no science. Pet food, I heard a statistic the other day that pet foods make up almost a third of Nestlé's turnover.
Holy smokes.
I was very naive.
It's a mega industry.
It's a mega industry. It's billions and billions and billions of dollars, and almost no science. So yeah, the supplements that are given, you can buy dog probiotics, you can buy dog prebiotics, you can buy dog supplements based on zero science.
Wow. So what are the dog probiotics? Are they just like bacteria that are easily culturable and stabilized?
So there is some data, I'm perhaps being a bit mean, there is some data on, canine probiotic strains, and there are some studies that have identified probiotic strains from, canine-based studies. But quite often what we simply do is take human probiotic strains because they're easy to manufacture and make, and then just apply them to dogs, and of course that just doesn't stand up
because their microbiomes are very different.
Correct. Yeah.
And does it extend further? Like if you have like a giraffe microbiome, do you think you could, like, is it all unique to a species?
Yeah, well, I think there is a degree of commonality because so much of our microbiome is defined by our environment. So for a human sharing an environment with a dog, there's a lot of overlap. Yeah. So in fact, we're quite interested. In fact, actually, my greatest claim to fame, I think, was being quoted. I think there's a headline, possibly in the Sun, it might be the Express, that says, Top Boffin says you should be kissed by your dog. And that was me. And because actually dog owners do absolutely share microbes with their dog. In fact, we know that having a pet is in fact a very good prognostic indicator of a long life and a healthier life. That might be because of lots of confounding variables. You go out exercising, you walk your dog, etc. But it's also because you share microbes. And having a pet diversifies your microbiome, particularly with kids. Like if you've got a dog in the house with a small child, it's a really good thing. Yeah, the dog will lick your child will lick the dog. They're going to share a bunch of bugs. Good and
do the bugs stay, or are they transient, they just pass through, or can like the dog bugs stay in the human microbiome and make the human microbiome more diverse as a result?
That's an interesting question. I think the majority are transient for kind of obvious reasons, but it'll be. I don't think we really know actually. Yeah. So that's one of the things
that's quite interesting.
We want to look
you become
at,
more dog then if you have.
But one of the things that we have discovered when looking at dogs is that you can see which dog owners are feeding their dogs human food. because their microbes adapt to metabolizing human foods, which they absolutely should not be eating. Right? So you should not be feeding your dogs chips, right? That is very bad, right?
I do feel it's steak.
Yeah.
He loves
that is
it.
Very pampered pooch.
Yeah. He really he goes crazy for it, actually. But that's okay. It's meat, right?
That's fine. As long as we can have it too.
Yeah. So if you feed your dog bad human food, not only are they likely to get unwell, their microbiome reflects that.
Yeah. But they will become unwell because their microbiome is humanized. They should not be having human microbiome.
So I'll move us on then from the dog microbiome. I was going to start with quite a provocative question.
Okay.
We've already dived into lots of really interesting stuff.
I can do provocative.
And that is the microbiome bubble burst? And by that I mean, all the hype, all the promise, has it just come to a head now and it's not as important as we once thought?
No, is the answer. It really hasn't, and we're just getting going. So I'll qualify my answer. So there is something called the Gartner hype curve, and it's a well-established, model for how innovations come to market. And if you can look it up and Google it, right? And we might be in the pit of despair here, but it's all going to go up again. And I think context is everything. The way I think about the microbiome is that we discovered a new organ 20-something years ago. Only 20-something years ago. Turns out this organ's super complex, really sophisticated. We have deep evolutionary links with it. It's evolving, it's dynamic. And it's taken us some time simply to work out who was there. And we haven't even done that yet, let alone what these microbes are doing and how they're interacting with our own very complex biology. And that's a really big scientific journey. We're dealing with really profound, complicated scientific problems. But the modern world doesn't have time for that. They want certainty, they don't want uncertainty, and they want answers, and they want them today. And we want to translate that into medical solutions that solve some of the world's biggest healthcare challenges. And what we've had is a rush into the microbiome space, and with that, the inevitable failures that come with it. And we've had some quite big failures. But I'm not at all worried about that, because that's inevitable in any branch of science. And I believe that the microbiome is so important to human health. It's so profound. I believe it's as important as our own genome in determining our risk of chronic disease or our risk of having a healthy, long life, good quality life, that it's imperative that we keep going. We understand and unpick some of those complexities. But I also think we're now starting to see some fruit from the last 20 to 30 years of labour, and some of that nuance being teased out. And I'm pretty confident that we'll see that translate into scientific breakthroughs.
Can we talk about some of the fruit? Some of those green shoots? Yeah,
we can. Before I talk about that, though, I think what you have to understand is also the culture within which we're trying to translate microbiome science. So medical science, clinicians on the front line, practicing doctors, are still quite a long way behind the microbiome curve. And that's not their fault. It's because actually we haven't translated a lot of these advances in our understanding of the microbiome into education for clinicians, and because they haven't necessarily had the tools to apply microbiome science into clinical practice. So whether that's measuring the microbiome in patients or having microbiome targeted therapeutics which they can give to their patients. But I think that is also starting to change. We are also trapped in a 19th century way of thinking about human healthcare. And that is almost exclusively defined by germ theory and this notion that all bugs are bad, basically. And almost all of the medical treatments that we have are designed to kill bacteria. So if they don't directly kill bacteria, they indirectly kill bacteria. And we do not leverage the microbiome at all in clinical practice, at all. So what you're really trying to do is to bring the clinical community, well, what I'm trying to do is to bring the clinical community with me a little bit, to evolve our thinking beyond germ theory into microbiome theory.
And the germ theory is basically bugs are bad, essentially.
It's basically bugs are bad. And the reason that was so important and so transformative is the thing that was most likely to kill you in the 19th century was a pathogen. You were most likely to die from pneumonia, tuberculosis or cholera. And you were, lucky if you got cancer because it meant you lived long enough. Whereas, of course, today, the things that kill us are mostly not pathogens. It's mostly cardiovascular disease. It's stroke, heart attack, obesity, diabetes. It's actually things that don't kill us, but which leave us in a very expensive, unsustainable, poor quality of life, which overwhelms our healthcare system. And the gap, if you like, the jump that we've not made is that microbes are also important in the causation of these problems. And it requires a shift in thinking, because it's not that there are pathogenic microbes necessarily that are driving these conditions, although that might be the case. It's actually that we're missing some of these really important beneficial microbes that maintain our immune systems, define and educate our immune systems as they grow, or define our metabolism or organ development. So that's quite a shift in thinking. And what it culminates in is a microbiome theory, which is really about a form of conservationism. It's saying actually microbial conservationism is a valid and important form of preventative healthcare. And it's as important as germ theory. And the way I think about it is that it's actually an evolution of germ theory. Pathogens are still bad. Of course, they still kill people. Sepsis is still a national problem. We have a global, HIV crisis. We've got a global, multi-drug resistant tuberculosis problem. We've got big problems with parasites and all the rest of it. So I'm not belittling them, saying they're not important. Of course, they're important. But equally, in the modern urbanized world that we live in, non-communicable diseases is actually the pandemic that is causing us the most problems, and microbes are really important in that story.
And where are these microbes going, and why have they disappeared?
So bacteria, we'll start with bacteria, right? So bacteria, of course, are the most dominant prokaryotic life forms, the most dominant life forms on the planet. They're the single-celled prokaryotic life forms. I've read a statistic somewhere that I think there are about 23 billion tons of bacteria under the soil alone, which are, there's only about 350, 400 million tons of humans, right? So in terms of absolute cellular abundance,
holy smokes.
Yeah, they're the most winning. But they're also the most diverse life forms on the planet, right? And bacteria have been here long before we've got here, and they'll be here long after we've got here, and we have co-evolved together. And bacteria and, archaea and, eukaryotic microscopic life forms and viruses are in and on everything everywhere. And in our modern lives, we've, of course, adopted this posture that they are bad, they kill us. But in fact, they are good. They are everywhere. We need them. So it's not that they've gone anywhere, but our society has become very aseptic. Like we are antiseptic. We are everything we touched during the COVID crisis, for example, was smothered in alcohol, right? And we also have consumed massive amounts of antibiotics and continue to consume massive amounts of antibiotics, which is very, very problematic. And many of those antibiotics are not used in healthcare, they're used in farming. And industrialized farming processes change microbes, as does urbanization, as does, pollution and all of the other features of climate crisis. So the way I think about it is that actually what we are experiencing is an internal climate crisis. We are experiencing a loss of, not just a catastrophic loss of the biodiversity within us that we rely on for health, but these microbes are also mutating. So it's not like we're just losing particular species of microbes. These microbes share genes and they mutate really, really rapidly because they have to adapt to this new world that we've forced upon them. And they can do that much faster than we can. Yep. So I think by some estimate, we've lost about 40% of the species within the gut that we used to have before probably we became domesticated. About 10,000 years ago, something like that.
And we can measure that through looking at tribes who are not industrialized?
Well, we can measure it by performing what we call metagenomic analyses. So looking at all of the bug genes within a sample from coproliths, so ancient fossilized species, right? And also by looking at dental samples from fossils that we find.
Interesting.
So, and you can look at the kind of oral microbiome evolution over tens of thousands of years.
Wow.
And what's interesting about that is, it comes back to my previous point, is that there, in a climate crisis, or in fact, actually, if you give antibiotics to to somebody, there are winners and there are losers. Right? There are bugs that will die out, and then there are bugs that will bloom. And that's the same thing that's happened in humans. So if you look at the kind of oral microbiome over time, lots of microbes have died away, and some have just been very, very successful because they thrive on an industrialized diet. Right? So Bacteroidetes, for example, have just absolutely bloomed in the human mouth. So yeah, there are winners and there are losers in a climate crisis, and that's part of the problem.
And how can we link this loss of diversity to some of the problems that we see, chronic diseases essentially?
So I think the first thing that you have to do is you've got to stop thinking in a siloed way. So many doctors, and I'm a doctor and I'm totally guilty of this, is that they just think about the particular problem that they're trying to solve. And the first thing you have to do is to look across lots of different problems. So when you start to look for patterns of diseases through the process of industrialization, a very clear pattern develops, right? And the first is that it's not just that, for example, cancers are climbing in their incidence, particularly in young people. It's that we've got a rising rates of immune-mediated diseases. So that might be bits of the immune system that drive things like allergy and asthma and atopy, or it might be problems that drive things like autoimmune diseases or problems like inflammatory bowel disease. We have a mental health crisis. We have, problems with, as I've mentioned, obesity, cardiovascular disease. Yeah. And the hypothesis is that there's a common driver of these things. There might be nuance and difference in the fundamentals of the biology, but there is a common driver. Now, of course, the causation is multifactorial. And of course, many of these things are driven by changes in diet, for example, or changes in digital culture, the way we use technology. But I'm arguing that because the microbiome sits between all of those environmental drivers and our genome, it is like the middleman in all of these processes. And the microbiome is the puppeteer of our immune system. And therefore, if it's dysfunctional in any shape or form, it becomes really problematic. And the other thing that you really have to understand about the microbiome is that it's not a constant. Like, it's dynamic, and by that what I mean is that it shifts with us through our life stages. So you're born with almost no microbes, and then you're cultured and you bloom, and then it turns into an adult microbiome, and then it evolves with us in our lifetime. So you see changes throughout an individual's lifetime, but also it's generational. A microbiome is passed from one generation to another, and what we're seeing is in about over the last 70 or 80 years. Is that the microbiome that's passed between those generations is changing really very dramatically. And
it's getting worse.
Yeah, I think it is. I think we have to say it is. And that is why you're seeing this rapid rise in these rates of these diseases, because it's a generational effect. So you've got a hyper-global generation which has got a hyper-globalized microbiome that is continuously hit with insult after insult after insult. It might be medicines, it might be antibiotics, it might be hyper ultra-processed foods, it might be an urbanized environment with a changing small social network.
It's a perfect storm.
And it's a perfect storm.
It's a perfect storm.
And then we're wondering why we've got these problems. And so that's why I think the simpler way to conceptualize it is of an internal climate crisis, right? Because people understand the language of a climate crisis. But the problem with phrasing it in that way is it's very frightening, it's very negative, it's very overwhelming. You think, well, what can I do? And therefore you have to offer solutions. And you asked me a question about 10 minutes ago, like, well, what are the exciting things that are going to come through in the microbiome? Well, I think they're going to be in solving those fundamental problems of an internal climate crisis.
I'd love to unpack all of that. But just before we do, one of the things which you talked about in your books, like a concept, and for listener, Dark Matter is the book you wrote. Very, very good.
Thank you.
I think it has to be one of the best ones. So it's like a reference point now for me when anyone asks, how do I learn more about this? I say, your book. It's really nice. And one of the concepts which I really liked was this, you called it microbiome scarring.
Yeah.
Which I think is probably yours. I haven't heard anyone else.
I totally nicked it.
Did you nick it?
Yeah.
Oh,
I think I referenced it properly.
I really like that. And the other one was this internal climate crisis. And one of the other things I'd like to talk about as well is, at the start of the book, you talk about this co-evolution, and I just touch on that a little bit. But the scarring then...
So microbiome scarring is a phrase or a term that's come out of the academic literature, and if your listeners are interested, I can send them the reference. There was a particular paper that was published by a team at the University of Washington that I talk about this paper a lot. It's really influenced me because they took a single antibiotic called azithromycin, which is a pretty strong broad spectrum antibiotic, and they gave it to a collection of healthy individuals. And then they compared that cohort of healthy individuals to a group of patients that had been in intensive care. And they followed the patients they'd given this azithromycin dose to for about, I think it was about 200 days. It was about 150, 200 days. And what they found was that in a sub-selection of these patients, all patients that were given the azithromycin had dramatic changes to their microbiome. So it's not just that they lost huge swathes of their microbiome, that they died out. It's that when they grow back, the microbiome that grew back was different, not just in terms of who was there, but the functions that these microbes had. So the metabolites or small molecules that they produced were just very different. And in a proportion of these patients, the microbiome never grew back. So 200 days out, one dose of antibiotics in healthy people, that was it. The microbiome was, it just was completely different to where it started. In fact, it was so damaged, it resembled the microbiome of a patient who'd come out of intensive care, who'd been hit with multiple courses of antibiotics, and dramatically altered nutritional states. These are super sick people. So, and this term microbiome scarring came out of that. And I think it's a useful way of thinking about it. Like you think about an Amazonian rainforest that's just been absolutely hit by a firestorm or just been chopped to the ground. I mean, that's exactly what's happening. And the soil dies. A single dose. And the critical impact, the critical learning from that is that can have a big impact as an adult, because that changes the way that you interact with your diet and your food. It changes the way you metabolize drugs. It changes lots of aspects of your health in quite a nuanced and subtle way. But if that happens at a moment of development where the microbiome is particularly vulnerable, namely in childhood, anywhere between birth to the age of about 5, then the implications may be profound for your risk of developing non-communicable disease later in life. And we see evidence from this in multiple epidemiological studies across multiple disease states. Everything from obesity to asthma to type 2 diabetes, cancers, almost, every single disease type. Multiple hits of antibiotics. So it's not just one dose of azithromycin, it's multiple doses of azithromycin consistently throughout childhood. So if you look at antibiotic prescribing, we prescribe globally about 38 billion daily doses of antibiotics each year. And the majority of those antibiotics are now not given in the developed world, they're given in low and middle income countries. So I read a statistic this morning, actually. So 1 in 3 children attending, the hospital for any reason, or their doctor in Europe will get an antibiotics.
Wow.
Will get a dose of antibiotics prescribed to them. But if you're in Uganda, the average child, I read, and again, I'll provide the reference for it for your listeners if they're interested, between birth and 5 will receive on average 59 prescriptions for antibiotics. Yeah, and it's very variable depending on where you are in the world, because antibiotics are just a blanket solution to all of life's problems. So the misuse of antibiotics is profound, and it's reshaping our microbiome in a way that we haven't really properly understood, because, again, we think of antibiotics in terms of germ theory. We think only about the pathogen, and increasingly we think about antimicrobial resistance. We think about the health problems that are happening because we no longer have these tools, and the chaos that's going to cause. I actually think about antimicrobial resistance as a sort of, obviously it's a disaster, but I also think about it as a biomarker for our failure to look after the microbiome.
Yeah, you're absolutely right.
Which is why I measure it in my patients, because actually if you've got lots of antimicrobial resistance genes, it means your microbiome is unhappy. There's something in its function that's probably not optimal.
And are there all these new approaches to try and develop new antibiotics which are more powerful, missing something, which is they're not actually thinking about the indigenous microbiota? So I've been to a couple of AMR events with lots of companies presenting, and they say things like, well, this new chemical entity or this new platform can potentiate existing antibiotics to make them even more effective.
Yes. Yeah.
I immediately think, well, they're going to be even more effective than at destroying the indigenous microbiota. And when you ask some of the CEOs, so have you thought about the microbiome?
I mean, it's
sort of scratch their head.
Well, they definitely haven't.
They don't, no.
Because
definitely don't.
but and it comes back to the beginning of our conversation,
Yeah.
which is where is the commercial incentive to do that, and have we properly explained the value in doing that, which is immense. There definitely is value, but it also raises existential questions because one of the problems we have in the microbiome science is that we're identifying novel pathogens or pathobionts, so perhaps normal members of the community, which actually, if not treated correctly or become relatively overabundant, can cause a disease, right? So Fusobacterium nucleatum would be a good example in bowel cancer.
Yep.
So what the hell do you do
When you've got
once you've got it, right? Because the best example is H. pylori. So Helicobacter pylori, Barry Marshall won the Nobel Prize for its discovery, transformed, my job. I'm a surgeon, I rarely repair ulcers anymore because we just give everybody antibiotics and we give everybody, proton pump inhibitors. Right, because we discovered that a bacteria, in fact, uprooted all of the dogma around why we get ulcers and turned out to be the cause of everything. The problem is that if you begin to eradicate H. pylori by giving everybody massive doses of broad-spectrum antibiotics, you inevitably cause secondary problems because the microbiome is a complex and sophisticated system. So you see in the epidemiological data rising rates of asthma and allergies and all of these immune-mediated diseases that we saw as a direct consequence of that. Marty Blazer goes on about H. pylori. He's the man for that. Read his book. It's really, really good. So what microbiome science has to do is to find new technologies, new ways that are very, very highly selective for still killing pathogens, because we need to do that and knocking them out, but at the same time maintaining the resilience, health and function of the microbiome. And you can't do that without understanding the microbiome. And the best example I can give you is probably phage therapy. What you are seeing is new companies, new startups coming online who are engineering phage in a scalable way to very precisely target, bad actors that we do need to knock down that perhaps don't disrupt the rest of the microbiome.
Like Fuso.
Yeah. Or maybe it's a case actually, and in fact I often describe myself now really as a sort of clinical horticulturalist. Like most of my time is like spent trying to sort of resurrect dead microbiomes in patients that have just been given too many antibiotics. But actually, again, quite often the way to maintain resilience in a microbiome is it's invariably not through medicines, right? It's through giving them the right nutrition, the right sustenance that they need to maintain that ecosystem.
Can we just go back a little bit to this co-evolution, which is how you start your book. So maybe just help the listener understand, why are the microbes in us? Like, why are they there at all? Because that rolls into, well, what do they do and why are they important and why do we need them? So the sort of, we do need them and they kind of need us.
Yeah, they need us. So
symbiosis.
I think, we know that single-celled life forms have been on the planet now for certainly 3.5 billion years, probably a bit longer than that. And extremophiles existed on the oceanic floor, from time zero, basically. And of course, we have co-evolved with them. So if you go back to about 600 million years ago, the first primitive worms turned up on the ocean floor, and they had a gut lumen, and we know that because some quite clever scientists have been able to scan them and recreate them. And of course, that was the moment that microbes first entered living systems. Microbes probably had a symbiosis before that because they were probably on the skin, and they were probably, influencing the evolution of eukaryotes, so complex life forms, because, for example, there's this theory of phylosymbiosis. So sort of typical Darwinian theory explains that what happens is that you have a random gene mutation that confers a survival advantage, and because survival of the fittest, that mutation will then potentiate. And there was this sort of super clever evolutionary biologist called Lynn Margulis, who was married to Carl Sagan, and she sort of came up with this idea.
Superpower couple.
Yeah.
So brainy. super intelligent. I wonder what they talked about.
I think they got divorced in the end, so probably
the origin of life.
Maybe they were too clever. I don't know, but anyway, so she came up with this idea of phylosymbiosis, and this idea that actually evolution, these kind of key evolutionary events occur when these two worlds collide, right? And the best example of that was mitochondria. So when, an ancient archaeon, this kind of super ancient extremophile was incorporated into the cell of another animal that created the energy device that kind of triggered all of human life, right?
Best merger ever.
Yeah, or not just human life, all life on Earth. So bugs are hardwired into our most fundamental cellular functions. They have been responsible for the evolution of all of our organ systems, and that's not just our gut. It is our brain. It is our lungs. It is our kidneys. So they are not within us by accident.
Yeah.
The microbes are there. It's not a happy accident. Yeah. Like, you need them. You need them and they need you. It is absolutely like a co-evolution.
So what you're saying is not only are they present on our skin, in our gut, in every orifice, so on. If you go back even further, the origins of our cellular makeup are, in some respects, microbial.
Correct.
Because the mitochondria, the energy powerhouse within our cells, is actually, we think, the derivative of a bacteria.
Correct.
That's how
an archaean.
An archaean. That's how successful they are.
Yeah, exactly. Right.
So they're fundamental. Yeah,
and you find lots of these other kind of clues in lots of different, other animal species and lots of different, lots of different organs. So I think there's a body of evidence for this partnership, and every time we've hit an evolutionary fork in the road, some of those microbes have, perhaps influenced the decisions that we've made to go one way or the other, or they've hopped along with us as passengers because they just happen to have some sort of benefit. Sometimes they might have caused the demise of entire species as they sort of knocked them out because they were highly pathogenic. So, they continue to do that today. Yeah. So, and that's why this climate crisis is so important. It's why that their ability to mutate and adapt so much faster than us is so important, because they are shaping our development today as we speak.
And it makes it, when you think about it like that, I guess the antibiotic piece really makes sense because that's new on the block. But if you think about the co-evolution and how the world was when the symbiosis started, there wasn't clean environments, there was no tube station, there were no medical procedures, there was no alcohol, there was no ultra-processed food. It was all just forage, survive and live. That's how the microbiome originated. So humans back when, hundreds of thousands of years ago, were living in a very, very different world to we are.
They were, but antibiotics were still there then. So I think there's also a misconception about antibiotics. So antibiotics are... they are naturally produced molecules by microbes and fungi in the soil, and they have been in and around us since we have walked the earth. So if you go back to Nubian, mummies and you sequence their microbes, you will find antibiotics in their gut, right?
Because, and AMR? Sorry? Is there must be then antimicrobial resistance back then, yeah.
In fact, so beta-lactamase, so some of the enzymes that kind of drive that, for example, they're ancient genetic mutants that have been present for millions and millions and millions of years. Wow. So they're not new. And in fact, there is a theory that there's a kind of philosophical question: what is an antibiotic? Like, we think of it as a bactericidal, molecule, so a molecule that kills another bacteria. Yeah. But actually, that's because we use it in massive doses. There is a theory that actually it's just a signaling molecule, that when used by one bacteria to communicate with another bacteria, actually it may not be bactericidal. It may be a way for shaping ecosystems and for reconstituting and keeping systems in check, that actually is necessary. You need it, right? And what's happened is that we've just completely usurped that signaling cascade and used it as a kind of hostile weapon of war and waged war on microbes with it. And the problem with antibiotics,
super high potency, injected.
The problem is that 80% of antibiotics are actually used in farming. They're not used in healthcare, and therefore these antibiotic resistance genes and antimicrobial molecules are in our water supply. They're in our soils. They're in our foods. They are in Antarctic tundra, like they are everywhere, right? They are endemic. You cannot escape them. And so I would argue that antibiotics have not just reshaped the human microbiome, they have reshaped the planetary microbiome. And actually the planet relies on microbial systems to cycle oxygen, carbon, phosphorus, all of the essential elements that we need to keep the whole show on the road. And at the moment, they're pretty confused, I think.
I mean, that's a bit scary.
Yeah.
Is there any way to avoid them if they're in the food supply?
Not really.
Well, so I guess that's the next logical step in this conversation, I think, is we've all got a compromised microbiome.
Yeah.
In some respect.
Yeah.
Because we're alive today.
And we're living in London.
We're in London.
Yeah.
Some of us have a dog, so we're getting some benefit from the dog.
Yeah.
What can we do? What can we do today? And then we'll talk about what we can do in the future.
So I think the first thing I want to say is that I am optimistic about the future. I think it's currently in the world.
That's good.
As we're sort of currently facing nuclear Armageddon, I am optimistic.
Yeah.
And the gift of the microbiome, and you started asking me, like, are we past peak microbiome? Absolutely we're not, because the microbiome is the solution to this problem. And the gift of the microbiome, the most important gift of the microbiome, is in the prevention of disease and the optimization of not just human health, but planetary health, right? So if you understand it, you can protect it, you can regulate for it, and you can engineer it to solve some of our most fundamental problems. Right?
Just as an aside, if there was nuclear Armageddon, there would only be a few survivors, and they'd probably be...
Yeah, there'd be bugs.
They'd be bugs.
Yeah, exactly right.
They'd win again.
Yes, exactly right. So look, I think again, until you understand the problem, you can't begin to fix it.
Yes.
And the microbiome is the missing piece in this. And actually, it's kind of, for the first time, I think, was it COP28, when antimicrobial resistance became one of the outcomes that they were actually signed up to. So the importance of microscopic life forms in the planetary crisis is now coming into the agenda. It's now coming into the discussions the WHO are having about human health care. And actually, like, I'm quite radical on this. Like, I think the microbiome should be enshrined in the way that we protect our most vulnerable people in society. And I actually think that the maternal microbiome in particular should be a basic human right. Because I think if you don't have an optimized maternal microbiome, the infants that mum is gestating will be at a lifelong disadvantage and at lifelong risk of non-communicable disease from which they perhaps can't ever really escape. So the microbiome it's that fundamental in my eyes.
So the listener will have lots of questions around, what can I do to improve my microbiome? How can I stave off the internal climate crisis? What are some of the key themes that you talk about with your patients when you're advising them about how to make things better?
So I think patients and someone who's sat at home listening to this and well are quite different, because patients, I think, that implies you've got a disease, an organic problem that we're trying to fix, or perhaps you're on very specific drugs. But I think if you're sat at home and you're well and you're thinking, well, what do I do? This all seems a bit overwhelming. I think the first thing is there are lots of things that you can do that are really pragmatic and simple. And most of those things are actually pretty common sense and you probably think about already. So given our conversation, number one is don't take antibiotics unless you really, really need them.
Yep.
So if you're going to the doctor with a bit of a cold and your doctor says, actually, it's just viral, you really do not need antibiotics and really do not take them. And if you are going to take them, it means saying to your doc, okay, let's do some cultures and let's find out which particular bug I've got and what is the most targeted antibiotic that I could give. And if I'm going to do that, how do I protect the bugs that I've got within me whilst I take that antibiotic? And we'll get onto that in a minute, but there are some things that you can
Just
do.
imagining saying that to a GP who's got 50 appointments in 20 minutes.
Right.
I listened to Mr. Kinross.
Yes, and he says, yeah.
But you're right. You're so right.
But at the same time,
right.
And I have to say this every single podcast I do and every time I speak to anyone.
If you need antibiotics.
I'm not anti-antibiotics, right?
Yep.
So I prescribe them. I'm like, I can't do my job without them.
Yep.
I'm a surgeon. If I didn't have them, my patients would die of sepsis and it would be very bad. So if you need them, that's okay. The other thing that you can do is think about where you're buying your food and whether or not antibiotics have actually been used in the preparation and farming of the meat you're eating or in the preparation of that food. And you can ask, and your butcher will know if you've got a good one, or they might not know. but ask.
That's
And say that it's important. If you go to the United States, they have a different set of regulation around this. Europe has a different set of regulations around this. The UK is very far behind. Post-Brexit, we were supposed to have new legislation around the use of antibiotics in animal husbandry. We don't use them as antimicrobial growth products anymore, but we do use them in animal husbandry, and there needs to be better regulation on that. And if you don't ask the question, you won't change policy. So you've got to keep asking the question. Mm-hmm. The next thing that I think is obviously really, really important is your social connectivity. So I think quite often in the modern world, we are isolated. Our family size is changing, but we're also digitized, right? So we meet on Zoom, we meet on Teams, or whatever your poison is. You know, we are on the phone, and we're not as connected. The microbiome demands a real world connection. Right, it can't survive in a digital world. So actually what you need to do is digitally detox. And that means if you're going to cook a meal, it means, you know, eat it with people, sit at the same table and share that food with that person. It means if you're a teenager listening to this, go and hang out with your mates. It's important. You know, I think, you know, that sort of, we know, for example, from lots of studies on teenagers, that teenagers with big social networks have more diverse microbiomes. That we just know that they do. And that's the same in lots of different other cultures.
Yeah. And that diversity theme has come through quite a lot today. Might be worth exploring a little bit. So is diversity a proxy for good in the microbiome, health?
I think most people understand that biodiversity is a broad measure of health, because if you're a rainforest and you've got lots of species of trees and lots of species of animals and lots of species of insect, that rainforest is much more resilient. It can deal with a storm, it can deal with a fire, it will regenerate and it will rebirth itself. And all other ecosystems are the same. So, you know, whether you're a barrier reef or a desert prairie, it's the same. And really your gut or your human microbiome is no different in that respect. Biodiversity gives you resilience in the face of harm, and it gives you the ability to adapt to an ever-changing world, and it's a basic measure of health. But I think what we are beginning to understand is more precise measures of what an optimal microbiome is. Where we're missing at the moment, and perhaps the reason why biodiversity becomes a commonly used index measure, is what is a healthy microbiome? I still can't answer this question, and I'm a microbiome expert, apparently. So
gets asked a lot.
I get asked, like, what is it, right? And that's why I never use the word dysbiosis, because dysbiosis implies that you know what a healthy microbiome is, and you know that it's become abnormal to a degree, and then it's causally associated with a disease. Quite often,
I just press you a little bit? Because I think I'm quite sure that you could, if you looked at some sequencing data, tell if a microbiome was more quote-unquote unhealthy versus healthy. So with all of your knowledge, I'm sure you could say, well, the diversity index is X. It's a lot of short-chain fatty acid producing genera in there. There's a lot of Fecalibacterium, Parasitia, Akkermansia, Musophilia. That's looking quite good. And this other one that I'm looking at has got a lot of Fuso and a lot of Proteobacteria. It's got really low diversity. Wow, there's a lot of antimicrobial resistance. Could you not kind of do that? Are we there yet, or is it too big a jump?
So you can kind of do that, and I do that. Yeah. So I don't disagree with you, but I think there's a couple of problems with that. The first is you've really got to define what you mean by health, right? And health is, you know, not just the absence of disease, right? And also health exists over time. So there's what's good for you today and what's good for you tomorrow, and the other problem is, of course, if you've picked up the short-chain fatty acid problems. Like, well, having too many short-chain fatty acids can also be a problem, right? And actually, what you need to measure the health of the microbiome is probably more than one test of it. So sequencing only gives you so much data. What you really want is a measure of function, and you want that measure of function over time. So I think about the health of a microbiome probably in terms of its resilience and plasticity. Can it deal with an injury and can it sustain itself, and can it adapt to whatever stress it is that we're putting it under, and is it consistent, and is it meeting not just the specific requirements to optimize the function of the organ that you're measuring it within, but is it also meeting the requirements for all of the other organs that it needs to support.
And just, if we can go a bit technical for a little bit, is a diversity index a measurement of plasticity and resilience? Or is that too simplistic? Is it too much of a jump?
I think if you asked an ecologist or a data scientist, they would say there's lots of different types of diversity, right?
Yeah, sure.
And often we talk about things like alpha diversity and beta diversity. So basically, is there a good distribution of different types of bugs within a system, and how does that vary between other people? So do you have more or less than other people within a cohort? And we can measure that with lots of different tools. And I think that probably gets to the hub of the matter, which is that in terms of microbiome diagnostics and microbiome testing, like, we have no agreement or consistency yet in which of these tools we should standardize. It doesn't have to be right, doesn't have to be wrong. It's just that we've all got to agree on the same one and measure the same one the same way consistently.
We're a long way away from that.
And I don't think we are, actually. And I think we're starting to get to a point now where actually, as microbiome testing hits the clinical domain, that actually you're starting to see several initiatives around the world to try and fix that problem. And that means, for example, creating standards for the assays that we use, or standards in terms of the microbes that we might want to detect within a system, so quality assurance processes, as well as standardizing the language and tools that we have. And I think probably one of the outcomes from that discussion will be that there isn't one way to measure the microbiome. You probably need multiple different platforms to do it.
So there isn't one test for plasticity or resilience. It's a combination. So I took us off piece. I'm sorry. I will come back to the microbiome testing, because there's a lot to talk about there.
But we were talking about, just because there were one or two things that I just think were important. Yes. Because we were talking about, like, what can you do?
Yes, and we talked about social interaction. We talked about food supply. And antibiotics, type of food. We should
but I mean, diet you have to talk about, right?
We've got to talk about diet.
So diet is obviously super important.
Only take antibiotics if you really need to, and if you really need to, you should ask for some culture workup to understand, and just some sensitivity analysis.
I'm going to throw one other kind of really controversial measure in there.
Okay.
And you should be vaccinated.
How's that controversial?
Because people just have really weird and strong views on it, and every time you talk about it, it's just like there's like a million comments on it.
Measles, mumps, and rubella are very bad things.
There's a very simple reason. Like, if you're vaccinated, you take less antibiotics. And vaccines they're like precision strikes designed to knock down or prevent you from getting, bad pathogens that cause you lots of harm. And it's not just that you stop taking less antibiotics; your community stops taking less antibiotics. So actually, you've got to take advantage of the tools that you can.
Let's talk about diet then. So, is there? If I had £1 billion and I came to you, I said, Mr. Kinross, I'm going to pay you all this money. You're going to create the perfect diet for my microbiome. And you can use all the technology and tools in the whole world, all the sequencing. What would it look like?
So before I answer that question, I will answer that question. I just wanted to say one other thing, that your microbiome also determines how effective a vaccine is. So, and we know that. So actually, like, you need a healthy microbiome to have an effective vaccine.
And maybe other drugs.
Yeah, well, maybe we'll talk about that
let's
too.
Let's talk about that as
well. But coming back to your diet question. So there is a rush at the moment to personalize nutrition. And there are lots of companies out at the moment promising that they can do it.
Some have raised a lot of money.
Yeah,
big money.
And they continue to do so. And what I would say is that you cannot personalize your diet without some knowledge of the microbiome. You have to have it in your algorithm somewhere. But the question is, I would throw your question back at you.
Okay.
Should we be creating personalized diets for billionaires, or should we just actually be trying to solve some of the most fundamental dietary and nutritional problems that we've got across society at the moment that are driving problems like the obesity pandemic? And that's my problem with this. Like, I think that strategy is a very good strategy if you've got a medical problem that needs fixing. We know from really good, very old and very long-standing studies that if you de-westernize your diet, so if you put lots more plant-based fibers in it, hit that kind of magic 30 grams of fiber a day, you reduce the amount of saturated fats and animal fats that you have, you take out some ultra-processed foods, take out the refined sugars, minimize your booze, your microbiome will be happier. And you will live longer. Like, you will not get Your just 7 more grams of fiber per day reduces your risk of cardiovascular disease, diabetes, cancer, dementia, all of these problems. And so my answer to that billionaire would be, I will take that money and I will buy a Ferrari and I will go and I will drive and I'll buy a super yacht probably. But what I will just do is put you on some plant-based fiber because it's the best evidence way that we currently have.
Yeah.
Now, the bigger question there
the thing is people know though. If people say to me, well, what do I need to do to improve my microbiome? I say, I'm sorry, you already know.
Yeah.
Everybody already knows. It's actually quite simple.
So, but here's the rub.
But it's tough.
But it is tough. So here's the rub, right? Is that generally our guts are not very happy. So if you have a patient, like I see a lot of people with what we no longer call IBS, so irritable bowel syndrome, and they come and see me and I say to them, look, it's really simple. All you got to do is put 7 more grams of fiber per day in your diet and not do these things. They say to me, either A, I'm already doing that, and actually I'm not very well with it, I'm quite unhappy with it, or they'll say to me, if I do that, my life will be unbearable. I can't do that.
What you need to do is give, can I say this these days? I think I can. You need to give 10 of our capsules and then they'll reset the microbiome within 3 days.
Well, there you go. Well, there you go.
I can say that.
Well, you probably can say that.
Yeah.
So you've got some evidence.
We've got some evidence now, yeah.
So that's the problem.
Yeah.
The bigger problem, of course, is that it's got nothing to do with the microbiome. The bigger problem is that you've got very, very large, very well-funded companies with very, very overwhelming marketing campaigns, creating mixed messages and inadequate regulation to protect the consumer from these things. And so the microbiome is sometimes its own worst enemy. It gets misused, it gets misrepresented, it gets missold. That's because people, coming back to the very beginning of our conversation, they're in a rush to commercialize it.
Yes.
And they don't really understand, how it really works.
But also, people, they go on the internet and they type in, how do I improve my microbiome? They'll read an article that says probiotics. Okay, they Google probiotics, or they use some other search engine. And for a non-scientifically aware, trained person, they'll see some beautiful marketing that says, 10 billion CFUs, clinically evidence-based, some nondescript thing that's not really a claim, and they go, okay, I'll use that. And I get it quite a lot. People send me a photo of something, I've never seen it before, and they say, is this good? And I say, well, probably not, to be honest with you. And it's a shame, because it's overwhelming for people. They want a quick fix. Yeah. But unfortunately, there isn't really a quick fix, is there? It's a lifestyle change.
So there's a couple of really interesting points you've raised in that one question. So the first thing is that probiotics are not drugs, and it's a living system, and therefore it's not quick. You're dealing with, microscopic organisms that need tender, loving care and nurturing, and there is no quick fix. The second problem is that you're right. The marketing language is, I don't know if I can use this language on this podcast, but it's bullshit.
Yes.
And so you've had this kind of marketing of good and bad bacteria.
Yep.
There is no such thing as good and bad bacteria.
It's context.
We shouldn't anthropomorphize our microbes. There are pathogens that will totally cause you harm, and there are mutualists and commensals. And the problem with good and bad bacteria is that if you treat your mutualist badly enough, well, you'll get sick.
Yes.
They will bloom and they will cause you harm. Like all microbes under the wrong circumstances, if mistreated, will cause you harm. And it sets us up. It takes away any of the nuance in what we're really trying to do, what we're trying to achieve. And then the third problem is that we don't target these, probiotic agents at all. So if your billionaire example, well, in fact, one of the things that we do, I do it in my clinical practice, like you've got to measure the microbiome to know what's missing, to know what to give back.
Yep.
But we just don't target them. So a lot of primary care physicians, nutritionists, dietitians don't have any basic education on probiotics. They don't know which microbes to give when. The consumer's completely overwhelmed.
Yep.
And then we give no instructions on how to take probiotics. So actually, you're trying to get these microbes to engraft in the gut. And most of these microbes are not really supposed to be in the human gut. So what that means is that you've got to take them really consistently. You've got to take them every day, and you've got to take them sometimes for up to 12 weeks to get to what we call engraftment, so that these bugs will actually consistently grow in the gut, and you'll be able to reap the health benefits from them. Most people just don't take them that way. And then the final problem is that, of course, these probiotics are also heavily marketed. They're usually very expensive. They're usually on some very expensive subscription model.
Yep.
And either patients are sort of guzzling them intermittently, spending quite a lot of money, or they're having side effects. And so quite often patients will come to my clinic and they will sit down and they go, look, I've been taking X brand. I've got this awful bloating, but it's doing me good. So I'm just, I'm still going with it. I'm like, well, why? Stop.
Yeah.
It's not doing you good. You're in pain. You're suffering. I spend quite a lot of my time taking patients off probiotics.
Wow.
I use them in my practice.
Yeah.
But they're a tool. And they should be used in a targeted way to solve a very specific problem. And I think that is what's going to happen with probiotic technology. So again, coming back to one of your earlier questions, I think we are now on the verge of next generation probiotic therapies, which will not be food stuff. So at the moment, probiotics are regulated as foods, and the health claims are based on, the ability to identify very specific, strain-specific mechanisms that are mechanistically or causally associated with a health benefit, which is very, very hard to do. So most commercial probiotics are foods that make wellness claims that are very broad and non-specific. The future is next generation probiotics, which actually do make wellness, health-based claims on evidence, and actually I think they'll be regulated like medicines. So the FDA will say, no, this is a medicine and it will be prescribed.
Very often I get kind of a grumpy, skeptical investor or pharma executive say, well, is it ever going to be as good as changing your diet? Precision, next generation probiotic.
Yes, it is. Because there's a couple of reasons for that. As big an advocate as I am for diet and health, diet requires sustained behavior change over time. And it's really expensive in a cost of living crisis. And it's really hard to do. And if you can get to a single strain that has a very precise mechanism, that has a very specific health effect that you can give in a more cost-effective, targeted way, well, then that is really valuable. All right, and the best examples of that would probably be things like psychobiotics. If we really can create single strains that can help treat conditions like depression or anxiety or these sorts of problems, well, then, there's going to be a massive market for those, 100%.
You may have seen our press release last week. We showed that in our drug groups in the cirrhosis trial, there was an improvement in the hospital anxiety and hospital depression scores, not in placebo, with a stronger trend in the higher dose group, which suggests that maybe there is, I know it's a small study and we have to caveat, maybe there is this gut-brain axis, and maybe they are producing metabolites that have some properties that influence how we think and how we feel. And it just seems so desirable to have something like that which is well tolerated versus some of the more heavy going, traditional neurotransmitter modulating drugs, which,
Well, I mean, look, the mental health crisis is, again, it's multifactorial. And yes, the gut brain is part of it. And of course, there are lots of external environmental drivers for it. And there, I'm sure, are lots of very strong and important heritable drivers as well. So I'm not suggesting by any stretch the microbiome is a panacea. But the drugs definitely don't work. And we're taking masses of them. Right, so I read some terrifying statistic that's about, I think, 16% of the population now take an antidepressant. It's an astronomically large amount. And
younger people too.
Yeah, and it's younger people, right? And it all went up after COVID, of course. Yeah. And medicines like SSRIs, they are not only are they antimicrobial, they kill bugs in the gut, but they also promote antimicrobial resistance, and the microbiome changes how they work. Right? So the bug-drug interaction that we were going to talk about, is particularly important in mental health. So it's not just that you might be able to develop novel therapies that target gut-brain interactions that either rely on single strains or perhaps take particular functions of microbes that you can, that are druggable, that you can create drugs from. It's actually the microbiome becomes an adjunct therapy to other well-established medicines or drugs that either protects the microbiome, promotes gut health, or maybe improves the way these medicines work without so many side effects. And I think the microbiome's got a big opportunity in that space.
We talked very, very briefly about this testing of the microbiome. So can you tell us a little bit about what you do in your practice? Like, how do you test the microbiome? How does it fit in? And then we'll segue into the at-home microbiome testing.
Sure. So I use my tests selectively, and I use a very specific type of test, is the first thing to say.
Okay.
So I use it as part of a diagnostic pathway. Microbiome testing is not the be-all and end-all, and I only use it in quite specific clinical conditions. So I use it, for example, in functional conditions of the gut, where the microbiome we know is very important, and actually having an understanding about diversity changes or specific strains is very, very important. I use it in antimicrobial, post-antibiotic gut problems, and I will use it in conditions where I think, if I'm thinking about targeting nutritional therapy or dietary intervention, or I want to give a probiotic, these sorts of things, I use it.
Just on the functional conditions, do you use the term IBS anymore, or you don't?
So IBS is a terrible kind of 19th century moniker, which I find to be very dismissive and patronizing.
Yeah.
Like it really belittles the symptoms that people have that suffer from it. And the problem, there's two big problems with it.
And syndrome.
Yeah, it's not a syndrome.
It's not a syndrome.
It's a constellation of lots of different conditions. And actually, it's not necessarily a primary problem of the bowel. So now we talk about disorders of gut-brain interaction. And really, these are quite specific conditions. I think the other problem with IBS is that we tend to really just focus on bowel symptoms. So we focus on constipation, diarrhea, or whether you've got a mixture, right? And then we give a bunch of medicines to manage constipation or diarrhea, right? And we completely miss the point of what's going on. Actually, what most of the time, disorders of gut-brain interactions it's really a chronic pain condition.
Yep.
And there are very gender-specific or sex-specific differences in the presentation of this condition and the mechanisms that underlie it, and it's obviously multifactorial. And when you reframe it as a disorder of gut-brain interaction, actually the therapeutic options become much broader and much more important. And I've completely changed the way that I manage that condition now than I did 5 or 10 years ago.
Why do you think the kind of low FODMAP approach is so successful in so many people?
Well, I don't think it is that
short term anyways.
Yeah, it works quite well in about 30% of people. And again, you really need to target it. And that's one of the reasons, for example, I will use microbiome testing because it's so dependent on microbes. It's very helpful to know what microbes are in the gut before you administer it, because FODMAP's super restrictive and difficult to do. It's pretty miserable. And these patients need a lot of support to do it. So I'll only do it with a dietitian. And it's so successful because there are so few treatments that really work.
Yep.
Like the medicines that we have are not good. Yep. And it's evidence-based, and it's got a mechanism, and doctors understand it, and they can say, okay, here's some recommendations for it.
It's purely microbiome as well, really, isn't it? You're changing what you're giving to the bugs, and therefore their metabolic activity changes. Correct. And then that has an effect. Yeah. So that's pretty interesting. So in terms of then the testing that you're doing, how useful is it? You say it's part of the toolkit.
It's part of a toolkit. Yep. So again, my job as a doctor is, of course, quite often to rule out organic pathology and diseases that probably have nothing to do with the microbiome that I really need to treat with an operation or a medicine. But once I've done that, quite often I'll be looking for therapies which do not rely on antibiotics or do not rely on medicines and do rely on targeting the microbiome. And to do that, you've just got to have a measure of it. If you don't have a measure of it, then you can't. Then you're just making it up. You're guessing, and we should not be guessing in the 21st century. And
is the analysis that you do more sophisticated than some of the things that patients can pay for themselves? So there's this booming industry, as you're very well aware of.
So the direct-to-consumer microbiome testing business is the Wild West, and nothing upsets me more than when I have a patient with metastatic bowel cancer. It happens to me quite frequently. They come in and they said, look, I've done the Zoe app test. It just makes me so upset because not only have they wasted their money, but the advice that they're getting is just completely not relevant to their problem, and in fact, it's probably doing harm
because they've got the condition.
Yeah. Right. And again, the problem with the microbiome testing, direct-to-consumer testing market is that there is absolutely no standardization. There's absolutely no consistency, and most of them are based on 16S short read sequencing. And the significance of that, if you don't know what that is that it doesn't give you any precision in what you're measuring. So it will only get, if you're lucky, it'll get down to genus level of what's going on. And actually precision is really, really important.
And for the listener, there's 2 levels below that. We care about species and strain.
Yeah.
And it's the strains which are really the operational, metabolically active, cellular
we
elements.
really want to know the detail, right? And the problem is that because it's not accurate, it's very difficult to get consistency. So you can take the same sample, give it to 5 different companies, get 5 different results.
Yeah.
And then the bioinformatics, the computational bit is also very variable. So the data that you get is just... So I have some rules on testing. So number 1 is that microbiome testing, to be effective, has to be done longitudinally, like it's a snapshot. And what you really want to know is kind of some sort of baseline measure. And actually it's quite... I'm going to contradict myself a little bit. If I can persuade one of my patients to do it when they're well, I will, because that's how you know what their microbiome is, and that's your baseline. So it's actually quite useful to know. And you can buy a bank it, and it's in your pocket, and you can come back to it. But so longitudinal measurement is key. I use a long read sequencing approach. So I use, a technology which is a next generation sequencing platform that gives me very significant, a lot more detail on precisely what I'm measuring.
Tells you what you need to know.
So it gets me right down to strain level, so it gives me high precision analyses, and then it gives me very consistent analyses. So if I take the same sample and I repeat it 5 times, I get the same answer those times, right? And we've done all of that validation testing. And then I will interpret that data based to a degree on what that report says to me. So the report will give me basic diversity measures, and it will give me some targeted analysis of bad bugs, so pathobionts basically, and probiotic strains, and then it will make some inferences. It will impute some functional data on it. But quite often, actually, those data sets have to be interpreted quite carefully in the context of the very specific problem that you're looking at in that very specific individual. So it's quite hard work interpreting them. It's not particularly easy. So that means that I will then quite often have to kind of go back, look in the literature, try and really look into these functions and work out what's going on. And that means creating quite bespoke therapeutic approaches for individuals where you're really trying to selectively knock down very particular microbes that are potentially, overabundant. The good news is when you do it, it's really effective.
You've got lots of success stories?
I definitely, I really do. And I think also the thing that I really like about it is that you can show the patient what's happening. Like it demystifies everything. You can sit down with them and say, look, here is a map of what's happening in your gut. These are the bad actors. And it incentivizes them to change their behavior. So you can say to them, look, I need you to do the FODMAP diet. We're going to do it for 6 weeks. And then we're going to regrow the gut microbiome after it. And it gives you a new language to have that conversation. And you can say, look, here is what you've done, and here are the changes that you've made, and this is why you're feeling better. And then you just close the loop on the whole on the whole thing.
Now, sometimes in this podcast we go into a bit of a time warp. We've been going for quite a long time.
Well, listen,
but no. But there's a lot. There's a lot still I want to cover. I'm just trying to figure out how we get it all crammed in. We touched on something super interesting and very, I think, pertinent, which is how the microbiome can improve the efficacy or the effectiveness of drugs.
Yes.
And it would be great to talk about that, but also as a surgeon, maybe there's some themes there as well. Kind of make your surgery more effective, less complications, that kind of thing. So
sure.
Let's talk about that.
So my research group is very interested in trying to understand how bacteria modify chemotherapy drugs, both in a way that perhaps potentiates or influences how effective those medicines are, but also how toxic they are. So we spend a lot of our time studying bug-drug interactions in cancer therapy. And the answer is they play really quite a significant role, but it's never measured and very poorly understood. So, for example, the best example I can give you is a well-known example of a particular chemotherapy medicine called irinotecan, which is a super cytotoxic medicine that we give in multiple different cancer types.
Right.
And it causes a very miserable side effect of awful diarrhea. And we don't really know why it happens. Well, in fact, we do know why it happens. The reason why it happens is that bugs in the gut, particularly E. coli, have a very particular enzyme. The enzyme is called beta-glucuronidase. And it reactivates this drug in the gut, causing the toxicity, which causes inflammation in the gut, and it causes the diarrhea. And you can knock down that bacteria, the diarrhea goes away, patients have their drugs, their cancer gets better, their outcomes get better. So all of the toxicity for that drug is defined not by human genetics, liver dysfunction, it's defined by microbes. And we've got other examples. And we're starting to see newer drugs come out for the treatment of things like cancer, but also for the conditions of things like autoimmune mediated diseases. And those medicines are sometimes called biological therapies. And typically those medicines produce antibodies, or they are antibodies, or they regulate the immune system in some way. In cancer, we have a very new class of drug that are just transformative. They're amazing medicines. They're called checkpoint inhibitors, and they change how a particular cell in the cancer microenvironment called T cells work. And they basically switch on the immune system to target cancer, and they are just transformative. And the microbiome is a really important determinant of how those drugs work. And you can change the efficacy of those drugs by changing diet through the microbiome, by giving a fecal transplant through the microbiome, by, even giving supplements, actually. So suddenly the microbiome...
How big an impact, have we seen in terms of research? Can we flip non-responders to responders?
Well, so that's the million-dollar question, right? So can you engineer the microbiome to switch on these cancers so that suddenly they respond to these drugs?
Wow.
So there was an example, so there's quite a famous study that was published in Science. I think it was about 2 years now.
An Israeli group.
Yeah, well, there was a group
two.
And there was one at Memorial Sloan Kettering.
Yeah.
And this was the melanoma patients. These are patients with metastatic melanoma, and there were about 16 patients that had become resistant to checkpoint inhibitors, and they got an FMT. So these patients were dying. The cancer had progressed. They had awful metastatic disease. And in half of those patients given an FMT, they responded. Suddenly, they got better.
Incredible.
So the drug started to work again.
Yeah.
So there is now a kind of global arms race. And a lot of the interest in the microbiome has become focused on these biological and immunological therapies because it costs billions of dollars. Billions and billions and billions of dollars of dollars to make these drugs and to develop these drugs. And if they fail, it's a catastrophe. Yeah.
So I'm there in London this week for Jefferies conference, which is the biggest European pharma biotech investor conference. And there's a few microbiome companies here, but it's tough at the moment for microbiome companies. As you mentioned at the start, there's been a hype curve, there's been a number of failures. Some are pursuing checkpoint inhibitor adjuvancy just to see if they can potentiate. But my question for you is, the evidence base seems really compelling. Why are the biggest pharmaceutical companies not?
I think there's a couple of reasons for that. I think the first reason is they don't have to. They're making so much money.
Yeah.
They just don't need to. The second reason is that I still think they're very skeptical of it.
Yeah. How do we overcome the skepticism?
Well, I think there's a bit of work to do. I think we need to tease out the mechanisms, and I think we need to do the validation science. And you asked me at the beginning, do I think the microbiome hype is over? 100% not for this reason.
Yeah.
It's a super smart place to be, and I get why microbiome companies are targeting it. I would be. So yeah, I totally think it's valid. There might be some risk in it, of course, because it may be that actually changing the microbiome is quite hard. Maybe FMT isn't a particularly scalable way of doing that. I don't know. I think it should be. But I think it's a smart thing to do.
What are you most excited about in this field?
So I'm very excited about microbiome therapeutics broadly, because I'm a clinician and I want to do well for my patients. And I think we are on the cusp of having a genuine age of microbiome targeted therapeutics. But where I feel like the gift of the microbiome is greatest is in disease prevention. What I'm most interested in is the early life microbiome and the infant microbiome, and how we can re-engineer or seed the developing gut microbiome to prevent all of these diseases happening in the first place. I would so like to not have to treat inflammatory bowel disease. I would really like not to have to treat bowel cancer in young people. And
do you think it's that profoundly powerful?
Yeah, I really, really do.
A world without...
I think if you do not set up the early life microbiome correctly, you are on a path to non-communicable disease, which is very difficult to escape from. And so my work now increasingly is in infants and in babies. Like, there's no point, if you're trying to understand why a disease like bowel cancer happens in early life, there's no point studying it after the horse has bolted, like in adult life. You've got to go back to infancy. And again, you've got to join the dots. Like, it's not one, what we want is a sort of is a nice Nobel Prize for medicine where we've identified one bug that causes one disease and we knock it down and we do some really nice Cox postulate type science and we but that's, I don't think, is what's happening here. You're dealing with communities of microbes that get hit after hit after hit after hit, and they evolve with us as we age. And so the way I think about it is that there's 3 or 4 key moments in our early development where those hits, if they happen, the effect is then magnified throughout your life. So one is definitely during gestation, and it's the hit on the maternal microbiome. The second is probably, the early infant microbiome. So definitely within the first 100 days of life, possibly within the first 1,000. And then definitely there's one about, probably about the age of 5, when the microbiome is sort of set in its kind of adult construct. And then I think puberty is another one. And I think if you have these hits, one after the other, after the other, after the other, you just get a cumulative effect on the microbiome, and that just makes it almost impossible.
So as an entrepreneur in life sciences, I'm thinking, preventative, long studies, clinical trials, and women that are pregnant.
It's even worse than that.
So how do we make that reality?
Well, there is definitely money in the infant microbiome, right? And we know that because, of course, infant formula manufacturers make billions and billions of pounds. Yeah. The problem with that is that it's just so toxic and so controversial, because actually the most effective way of having a really optimized healthy infant microbiome is breast milk.
It's the real deal.
The problem is that actually some women can't breastfeed, some children don't get access to breast milk, and even if you can, you might get hit with antibiotics in early life for very legitimate and important reasons. So there is a very significant unmet demand for these sorts of companies that can go in there and do that work. They've got to find a new language and a new reference way of communicating what they're doing and engaging with mothers and infants. And we've got to learn the lessons that infant formula companies have made in the past. But I think there is an opportunity there. But I totally understand what you're saying. Yeah. Like, prevention is not sexy, and it's not the $1 billion. You're not going to go out and raise a couple $100 million bucks, for infant health. So, but to me, that's where all the action is. That's where that's where you need to be.
Wow. Now, just some very quick fire things then for the listener. Do you recommend probiotics to people who don't have a specific issue with their microbiome? So someone who's wanting to optimize their health.
So no, I wouldn't recommend a probiotic to anybody without measuring their microbiome, and I wouldn't recommend it if you're healthy. If you're healthy, what I would recommend that you do is you think very carefully about your diet. It's much, much more important. A diverse diet equals a diverse microbiome, and you can have a much bigger impact by having a consistent and sustained diverse diet that's optimized for feeding the microbiome. So I think that's a better thing to do. It's probably cheaper.
Yeah, almost certainly.
Yeah.
Are there any?
I do recommend kefir though. So I like fermented foods, and I recommend natural probiotics because they're probably as effective as most expensive commercial formulations, and
that's exactly where I was going to go next. So what else do you recommend then? So kefir, kombucha.
I love a bit of fermented foods. I do. Like I am one of those
Kimchi.
people. Yeah, love it all. Like my daughter loves it. She makes it, and so we eat it together. But I do. But again, it's like context is everything. Like if you're like humans, like we're just so frail, aren't we? Like you'll be munching on kimchi with your, sausages, and then you'll be necking, half a bottle of wine with it, right? That's the problem, right? So kimchi, as big a fan as I am of it, like it's not a panacea. Like having a bit of fermented food doesn't take away all of your problems. It's as important that you exercise. It's as important that you and that you do it regularly, and that you have, like I said before, like a real world social community that you engage with. And, again, these things are all time dependent. They're not constants with us. Our microbiome shifts with us as we age. And what you need when you're 20 is not the same thing that you need when you're 60 and when you're 70. So you have to be prepared to be dynamic with these things and to shift them with your body's requirement, I think.
If a listener wants to learn more, I highly recommend they read your book. Is there any other reference point that you'd recommend if they want to go a bit deeper they should listen to your other podcasts. And you've
Oh,
done a few.
definitely. Yeah. I mean, diversity is a good thing, right? And I think there are lots of other people out there saying lots of other interesting things. We talked about Martin Blazer. I mean, he's one of my kind of, heroes. So he's great, and he speaks very eloquently on this theme, and his book's really very good as well. Missing Microbes, I think it is. I think there are some other really, really good scientists at the moment out there, and I can send some links for your listeners who, if they're particularly interested. But I think just beware. I think there are a lot of people selling snake oil on the microbiome, right? And it's not a panacea.
There's so much.
It's a nuanced, complex science. And the problem that I have is that many of the patients that come to see me are really sick. They've been failed by medicine, the drugs are not working, they are vulnerable, and they're in pain, and they're miserable, and they'll try anything. And they invariably have tried all of the kind of social media solutions, and they've failed. And it's very easy for the microbiome to be anything that you want it to be, because there is complexity, because there is nuance. Like, you can sell it. Anybody can wake up and be a microbiome specialist, and there's a lot of people talking a lot of bullshit out there. So you just have a very sensitive bullshit meter. And if it's we said this at the beginning, if it sounds too good to be true, it's too good to be true, right?
That's a key theme that came out today.
Yeah.
Believe it or not, we are out of time.
Oh,
it's like a TARDIS.
A dream.
Or it just happens so quickly. So I wanted to thank you very much.
Thank you
for coming on and for
My
sharing
pleasure.
your wisdom.
No, I've got none. And listen, congratulations with all your work. I'm very excited to see what you do next.
Thank you, James. Appreciate it.
Yeah.